Hello guys, I'm going to start lecture 36. So in this lecture, I want to solve one example on heat equation. So in this example, you're going to find solution of following heat equation. So we have for derivative of u with respect to t, it's equal to second derivative of u with respect to x, when x is between 0 and 2. So we have boundary conditions. The boundary condition says that u of 0 and t is equal to 0, or temperature at 0 is equal to 0, and the temperature at 2 or at end of the rod is equal to 0. And for initial conditions, so we have u of x and 0, or temperature at t equal to 0, it's equal to 2 sine pi x over 2 minus sine pi x plus 4 sine 2 pi x. And here we have a note. So based on orthogonality of the sine function, we have the integral from 0 to L sine n pi x over L times sine m pi x over L dx is equal to 0 if n is not equal to m, and it's equal to L over 2 if n is equal to m. So if you remember, in the last lecture, we solved this example. So in the last lecture, we had an example. So it said k second derivative of u with respect to x was equal to derivative of u with respect to t, and we said x is between 0 and L. So we had two boundary conditions, u of 0 and t was equal to 0, u of L and t was equal to 0, and we had the initial condition. So we said u of x and 0 so was equal to x. So in general, I say it's equal to fx, but in the last example was equal to x. And then we solved this example, and we ended up with this result. So we said u of x and t was equal to 2 over L, the summation of n from 1 to infinity, the integral from 0 to L, fx sine n pi over Lx dx, e to the power of minus k n squared pi squared divided by L squared times t, and times sine n pi over Lx. So we found this solution as well. So you can go to the last to lecture number 35, and you can see this solution. I don't want to solve this problem again. So the new example, because we already solved it. So we just want to change the initial conditions to find what solution would be. So now we back to our example in this lecture. In this lecture, we have four derivative of u with respect to t is equal to second derivative of u with respect to x. If I compare it with the example that we solved in the last lecture, we can see that in this case k is equal to 1 over 4, and L is equal to 2, and fx is equal to 2 sine pi times x over 2 minus sine pi x plus 4 sine 2 pi x. So if I want to find u of x and t, at first I have to find this integral. So this integral, it's integral from 0 to L. So L here is 2. Fx, so we have it here. So it's fx times sine n pi over L is 2x dx. So if I plug fx in this integral, so we can see that it's equal to 2 times integral from 0 to 2 sine pi x over 2 times sine n pi over 2x dx minus the second part, so we have the integral from 0 to 2 sine pi x sine n pi x over 2 plus 4 integral from 0 to 2 sine 2 pi x sine n pi over 2x dx. So in fact, if we can find this integral, we have our solution. So let's solve this integral. Based on the note, so we have, and based on orthogonality of sine function, we have the integral from 0 to L sine n pi x over L sine m pi x over L dx is equal to 0 if n is not equal to m, and it's L over 2, it's n is equal to m. Let's find the first integral. So the first integral says that the integral from 0 to 2 sine pi x over 2 sine n pi over 2x dx, based on definition or orthogonality of sine functions, it's equal to 0 if n it's not equal to 1. Why? Because in this case n is equal to 1 here, and it's equal to L over 2, so L is equal to 2, 2 over 2 is 1, if n it's equal to 1. Let's find the second integral. Integral from 0 to 2 sine pi x sine n pi x over 2, it's equal to. So in this case, n should be equal to 2. So it means that if n is not equal to 2, this guy is equal to 0. If n is equal to 2, so we have 1. And let's find the third integral. In the third integral, so we have integral from 0 to 2 sine 2 pi x sine n pi x over 2 dx. So based on orthogonality, if n it's not equal to 4, it's equal to 0, and if n is equal to 4, this integral is equal to 1. So we could find integral of fx sine n pi over 2x dx. So in fact, this integral is equal to so 0 to the integral of 0 to 2 fx sine n pi over 2 x dx is equal. So we have 2 times this integral. We already found this integral here. So it means that it's equal to 2 times it's 0 if n it's not equal to 1. It's 1 if n is equal to 1, plus or minus the second integral, the integral of 0 to 2 sine pi x sine n pi over 2x dx. So it's equal to 0 if n it's not equal to 2, if 1, if n is equal to 2, plus 4 times the third integral. So we found it, it's equal to 0 if n it's not equal to 4, and it's 1 if n is equal to 4. Let's back to solution of this problem. We said solution of this problem, u of x and t was equal to 2 over L. L is equal to 2, so 2 over 2 is 1. Summation of n from 1 to infinity. The integral of 0 to 2 fx sine n pi over 2x dx times e to the power of minus k, so k is 1 over 4, n squared pi squared divided by L squared, so L is 2, so it's going to be 4 times t sine n pi over L, so L is 2, so n pi over 2x. And we found this integral here. So as a result, u of x and t is equal to, if n is equal to 1, what's this integral? If n is equal to 1, so if you look at here, you can see that the integral is equal to, in this part we have 2 times 1 is 2, and here if n equal to 1, so the function is equal to 0. In this part again is equal to 0. As a result, if n is equal to 1, we have 2, the integral is 2, e to the power of minus 1 over 4. So n is equal to 1, we have pi squared divided by 4t sine n is 1, so we have pi over 2x, plus if n is equal to 2, what happens? The integral of fx sine n pi over 2x dx, if n is equal to 2, so this part n is not equal to 1, so it means that it's equal to 0. So here we have n equal to 2, we have minus 1, and in the third part we have, since n is equal to 2, the third one is equal to 0, so it means that it's minus 1. It's the integral e to the power of minus 1 over 4, n is 2, so we have 2 squared is going to be 4 pi squared divided by 4 times t sine so here we have n is equal to 2, so we have 2 pi divided by 2x. So if n is 3, so what happens? If n is 3, what's this integral? So the integral, if n is 3, so here this part is equal to 0 because 3 is not equal to 1. So the second part again is equal to 0. The third one is again is equal to 0. As a result, this integral is equal to 0. We don't have any solution. If n is equal to 4, what happens? If n is equal to 4, the integral is equal to, so this part it's equal to 0. This part is equal to 0 here. N is equal to 4, so we have 1 times 4, so it's going to be plus 4 e to the power of minus 1 over 4 n squared, so it's going to be 16 4 squared times pi squared divided by 4 times t sine n pi over 2x, so n is 4, so it's 4 times pi divided by 2 times x. So what happens if n is equal to 5? If n is equal to 5, So this integral, the first part is equal to 0, the second part is equal to 0, and the third one is equal to 0 as well. So for n equal to 6, 7, 8, and so on, the coefficient, or this integral, the integral from 0 to 2f(x) sine n pi over 2x dx is equal to 0. As a result, the final solution is here. So in fact, I can say that u of x and t is equal to 2 times e to the power of minus pi squared divided by 16 t sine pi over 2x minus e to the power of minus pi squared divided by 4 t sine pi x plus 4 e to the power of minus pi squared times t sine 2 pi x is the solution of this problem.